In this video, I'm going to explain the cutter compensation options. Most contouring work is done with the side of the tool. To do this, the machine control must calculate a centerline toolpath offset to the left or right of the profile being machined. This offsetting process, called cutter compensation, is critical to precision machining. You must understand the strategies, limitations, and practical use of cutter compensation to program a CNC machine. To illustrate how complex this can be, look at the example shown. The finished profile is shaded. The tool center line is shown as lines and arcs around the outside and the inside of the part. Notice that as the toolpath is offset, entities must be added or subtracted to form a continuous path. The outside profile adds arcs to the sharp outside corners to make the tool remain in contact with the profile as it aligns itself with the next move. This rolls the cutter around the corner, producing a better finish. The inside profile removes internal arcs that are the same or smaller in radius than the tool. Compensation direction. Offset direction is in relation to cut direction. The best way to think about this is to imagine walking along the profile in the cut direction. If the tool lies to your left, cutter compensation is set to left. If the tool lies to your right, cutter compensation is set to the right. Cutter compensation set to left is the most common setting since it produces a climb cut for both inside and outside profiles. The simplest type of cutter compensation is where Mastercam calculates the offset. Coordinates in the G-code file represent the center line of the toolpath. This is referred to as cutter compensation in computer. Machine controls are also capable of offsetting the cutter. This type of compensation is called cutter compensation in control. Cutter compensation in control is activated with G41, compensation to the left, or G42, compensation to the right, and it's cancelled with G40, compensation off. With G41, G42, you must include a cutter offset diameter register, also known as D, that holds the tool diameter. These are usually the same numbers as the tool. T1 will have a D1, T2, D2, and so on. Wear compensation uses both the computer and the control to offset the tool. First, the G-code file is written to the tool center line, just like with computer compensation. A G41, G42 code is also added to the program, allowing the toolpath to be adjusted for wear and deflection at the control, as shown. With wear compensation, the control offset value acts like a small fudge factor that causes the tool to veer slightly left or right of the programmed path. In fact, if there is no tool wear or deflection, the compensation value in the control is set to 0. Since Mastercam calculates the majority of the offset, the control D register values are kept small, typically a few thousandths of an inch. Small compensation values produce far fewer control problems than large ones, so programs based on wear compensation are very reliable. Wear compensation has so many advantages over computer or control alone that it has become by far the most common way to use cutter compensation. You are encouraged to use the wear method if possible. In Mastercam, compensation is set to wear and the nominal perfect tool diameter is used to calculate the tool center line. Note that some machines require entering the radius of the cutter rather than the diameter. Some use registers 1 to 20 for length offsets and 21 to 40 for diameter. Refer to the machine operator and programmer manual for instructions on how to use cutter diameter compensation on your machine. This concludes the presentation on cutter compensation options.